Hello everyone, in this video I'll be covering properties in Python. But before we can get started with properties, I need to talk about getters and setters in Python. This is nothing special or anything. In fact, this is something that every programmer does when defining classes, even if they didn't know that's what they were called. I'm of course talking about the methods we define in classes to retrieve or set the values of certain attributes in the objects created from these classes. Methods like getName or setName or something similar to that effect. They may not always have the get or set prefix, but the methods that interact with object attributes are the getters and setters. Now, many people would argue against using getters and setters in Python. The main reason is because in Python, there is no such thing as marking variables private like in other languages. Marking a variable private allows us to specify variables as inaccessible from the outside. So in order to access or modify the data stored in these private variables without exposing the variable itself, we would need to define methods to get or set the data. But in Python, there is no such thing as private. Everything in Python is public. Because of this, you don't technically need to create methods to handle these variables. We can just access the variables stored in these objects directly. That's why many people argue against getters and setters. And they're not entirely wrong. In a lot of cases, that's all you really need, especially when you are just trying to get data. After all, one of Python's main characteristics is its simplicity. However, when it comes to setting data, it really depends. In some cases, accessing the variable directly is enough. But there are times when you need to validate the data before setting it because invalid input can potentially cause problems with your program. In this case, we would need to at least create setter functions in order to validate the input before assigning it to an attribute. So you may occasionally have to use function calls like this. Which now brings us back to the main topic of this video, properties. Properties are the Pythonic solution to getters and setters. Properties are attributes defined at the class level and they are used to control object attributes. They're just as easy to access as the object attributes themselves. Plus, they allow us to implement the functionality of the methods that we would normally use without the wordy method calls. But keep in mind, they should only be used for fast computations. Performing various input checks to make sure the data is valid is one thing. But if it's taking a not so insignificant amount of time to achieve its task, then it's recommended to just use regular methods instead of properties. Now let's take a look at a few examples. So in this first example, I'm going to show fully functional properties. So we've got a class called Pilot, and it just has a name and ID for attributes, and you may have noticed that I prepended them with underscores. And this is important because we want to make sure that our objects do not have attributes with names that will conflict with the property names. Then we got various functions here, I'll explain those in a bit, followed by these two lines right here. These two lines are defining our properties, and you may have noticed that I'm setting them to name and PID. So name, at the very least, is why I have an underscore before this name. It's so we can make sure that it doesn't confuse the attribute name with the property name. As for ID, it didn't really matter if I put an underscore before it or not because I did that. And that was because the Python linter was yelling at me for using what it thought was a function instead of an actual variable. And then I have a whole bunch of methods here that are important for our properties to work. So I'm going to explain those one by one, starting with these two. These two, which I've labeled as our getters, are the methods that we use to get the attributes. They will return the value of our attributes. So we have underscore get name and underscore get ID. Simple. And these getters don't take in any parameters. Some getters you can define to take parameters, but in order for getters to work with properties, they cannot take parameters. They just take self. Then we have our setters, set name and set ID. Now, again, if we're just building a custom method to set some values, we can usually put whatever we want in there. But in the context of properties, they can only take one other parameter, and that's reserved for the value, which you can call value and you can call it something else. It's up to you. And inside, we simply set the value to the attribute that the property is for. So we're setting the value to underscore name under set name, and set ID, we're setting the value to underscore ID. And then we have our deleters. These are less commonly used, but you can use them, and they simply just delete the attribute. So here I'm deleting the attribute name, and here I'm deleting the attribute ID. And so those are all our methods, our getters, our setters, and our deleters. So how do we use these methods for our properties? Well, when we're creating our properties, we pass the method names into the property object that we're creating. So the first parameter is the getter. The second parameter is the setter. The third one is the deleter. And then the fourth one is a description of the property. So in here, I put the name of the pilot, the ID of the pilot. Now, the description is optional. You don't have to put something there. You can pass in none or you can put a blank string in. You don't have to have an actual description in there. It's recommended to have one, but you don't need to have one. The description, though, is the equivalent of a docstring for the main property function. So if you were to put a docstring under the getters here, that's what this is. Now, at a minimal, a property has to have a getter. You don't have to have a setter and you don't have to have a deleter. If you don't want to use the deleter or you don't want to use the setter, just pass in none for their parameters and you'll be fine. But at a minimum, you must have a getter. Now, here's our example down here. I create two pilots, Crozo and Anna, and they get some ID numbers. I print out the initial values here. So I print out the values of their names and their IDs by calling their property names. So I call p1.name, which is this property, and p1.pid, which is this one. I do that for both of them. Then I change their values. So since I have given them setters, I can change their values by assigning the new values that I want to the property name here. So I'm assigning Victor to name, which is this property, and that's going to cause it to call this function here to apply that assignment to the attribute underscore name. And same with underscore ID, which I do for Anna's pilot ID. And then I print out the new values. Then I delete the values. There's not really going to be a printout for calling these, but using the delete keyword on both of these will cause it to call these deleters here. And then after I delete them, I'm going to check both of them to say, hey, does their attribute exist? And then to show you that the attribute no longer exists, I'm going to attempt to call out the property name for pilot 1. So I'm going to go ahead and run the example here. And so it prints out the initial values. Then I change the values. So I change Crozo to Victor, and I change Anna's ID to 112233, and it prints them out just fine. Then I delete their values, and then we get this exception right here when I attempt to access the property name for pilot 1. And the exception might be a bit weird, especially when you get to the attribute error, because we're accessing the name property, but it says that it can't find the attribute underscore name. And that's because the property is meant to access the underscore attribute. So that's what happens when you try to access an attribute through a property when it doesn't exist. And just to demonstrate that we can create properties without the deleters or without the setters, here's an example first where we leave out the deleters. So it's essentially the same thing, except we don't have the deleter methods, and in place of those deleter method names, we just leave the keywords none. So we're going to attempt to run this same code again, and the last thing we're going to do is attempt to delete pilot 1's name, and when we do that, we're going to get an error saying that there's no method for the property to delete it. So as you can see, for the most part, it works great. It still works the same way, but once we try to delete the property name for pilot 1, we get an error saying that we can't delete that attribute. And then here's an example where we don't have deleters or setters, we only have getters, which means that these properties are read-only for these attributes. So same as before, we're just reading out the values, but then we try to change pilot 1's name to Victor, and we're going to get an error when we try to do that. And as you can see, we get the attribute error that we can't set the attribute. And properties work with dictionary and list type attributes as well. In this example, we've got a dictionary called data that contains the name and ID of our pilot. And in this one, we just have a getter to return the dictionary. We get the dictionary, and then we access the key ID, and we set it to a new ID. And then we add a new key, ship, and we give it the name frigate. And then down here, I'm printing out the information twice after modifying it to show you that the data inside the object has in fact been modified directly using a property. Now you might be wondering, well, why am I not using a setter to modify the data instead of a getter? A setter is used to completely reassign the data. If we just want to modify a piece of the data, then we would just need a getter. But if you want to modify the data attribute completely, then that's when you would use a setter. A setter will completely override the variable with new data. It won't allow you to set specific parts of that data. When we want to modify something like a dictionary or a list, a getter is enough. See, all the new information printed out. And then of course I've got an example to show the same situation but with a list. We've got a list with numbers on it. We return the data with just a getter, and we can modify the data down here using the property and using normal list assignment. So right here, I access the 0 elements of data and I change it to -1 so that 1 will become negative. and then I append a new element to that list, the number 6. So we should get -1, 2, 3, 4, 5, and then 6. And again, I print out both as the property name as well as the attribute name. See? -1, 2, 3, 4, 5, and 6. Now, understandably, you may not like all this extra code in your class definition, especially if you will have a lot of properties and the function names you will need to pass in are a bit wordy. Fortunately, Python provides decorators for us to use in place of this. Now, when it comes to properties, decorators work a little bit differently. When we want to create a property using a decorator, we have to, by default, establish a getter. So for name, we have def name self return self underscore name. So there's our getter. And then on top of that, we have the decorator at property. That's all you need. When we want to create a setter, instead of referring to the decorator property, we actually start a new decorator that was created by property. So the decorator property will turn name into a property. But not only that, it sets up the property in a way that we can refer to the property name in a decorator format in order to set the setter and deleter for that property, which you can see down here when we establish our setter. So instead of at property, we have at name dot setter. So we're basically decorating this next method here with name dot setter to establish that it is the setter for the property name. And you may have also noticed that this method is named exactly the same as the method up here. When you're specifying your getter, setter, and deleter for a single property using the property decorators, all the methods have to have the same name. So our name.setter is called name. It takes in a parameter value, and we assign that value to the name attribute. The same thing with deleters. We have at name.deleter. It's just called name like the other two, and inside it deletes the name attribute. And the same thing with pilot ID. We established that p underscore ID is going to be the property name with the at property decorator. And to establish our setters and deleters for PID, we establish it with a decorator PID.setter and PID.deleter. And then we have our example down here, which is the exact same example as we had in the very first example. So when I run it, we have our initial values. We then change those values. And then like in the first example, we delete pilot 1's name and pilot 2's ID. And then we try to access the name of pilot 1, and we get the exception that the underscore name attribute does not exist. Now, there are a few good use cases for using properties. We've already seen the first one, which is to simplify the modification of attributes without needing lengthy method calls. Another potential use case is the dynamic computations of certain values. In this situation, there may be values that we need that are directly affected by other attributes that exist in the object. There are a few ways to handle this. The first way to do it is to have the property not only modify the attribute it's meant to modify, but also have it update the attribute that would be affected by this modification. So in this example, we have 3 attributes: first name, last name, and full name. Full name is updated whenever first or last name is modified. So we have the property first and last name, and they both have getters and setters. The setters not only modify the value of the attribute that they're in charge of, but they will update full name with the new value whenever that modification is made. So whenever we modify the first name, it will update full name with the new first name with the existing last name. And same with last name. Whenever the last name is updated, it will modify it with the existing first name and the new last name. And then we have a property getter for full name. It only gets the full name. It doesn't actually update it or anything like that. And then for our code here, we have our initial pilot, Victor Rotsev, which is just Victor backwards. And we're going to change the first name first to Krozo, and then we're going to change the last name to Oswork, which is just Krozo backwards. And then we print out the name each time, so we will see its original name, followed by the modified first name, followed by the modified last name. So when I run it, Victor Rotsev, Krozo Oswork. See? Another way to do it, and this is probably a simpler way to do it, it really depends on what you're trying to do, but in this case, instead of having the properties for first name and last name update the full name whenever they're modified, is simply to have a property for full name that gets the first and last name whenever it's called and returns it as a single string. So as you see here, the first name setter and the last name setter, they just update their respective values. And then down here we have full name, which every time it's called will return first name and last name together in a single string. Values are the same as before. It's just going to be executed a little bit differently. So when I run the code, we get the exact same output as the previous example. And this last example is for if you don't want to have properties for all the attributes, you just want to have properties for your dynamic attributes, like full name, then you can just have regular access to your normal attributes, first name and last name. As you can see here, we have no properties for it, so we're just accessing them directly. And then you have a property full name, which will give us the full name by taking those two attributes together, like the previous example, and returning it as a single string. So we should get the exact same output as the previous examples. And as you can see here, that's what we get. The last thing I'm going to talk about is error handling. The best way to handle any errors that can occur with properties is with exceptions. When we call regular methods to set or get values in an object, we can have them return none or Boolean values or even raise exceptions to indicate that something went wrong. This is one of the reasons why we use methods to handle attributes instead of modifying them directly. The immediate feedback that we can get on whether or not something happened or that something went wrong. This is useful when we don't want the incorrect handling of an attribute to cause our program to crash, at least not immediately. With properties, we can get that same ease of access we would get with attributes while also getting that feedback. Unfortunately, that feedback will be restricted to raising exceptions, and here's why. The only thing that getters should ever return is the value that you expect to get from them. If your property is an integer, then it should be an integer. I would say the only exception to this would be to return none. Otherwise, if for whatever reason the attribute for the property doesn't exist, whether it's because it was deleted, it just wasn't declared yet, or maybe something crazy happened, then you raise an error. And you can let Python raise whatever error it would normally raise in this situation, or you can raise your own custom one. So in this code right here, I have two properties, and we're going to use those to demonstrate all the different ways to handle errors for the getters, setters, and deleters. So for our property first name, the getter will check to see if the attribute exists first, and if it does, it will return it. Otherwise, it will return none. And then for last name, our getter simply just tries to return the last name. And if it doesn't exist, then Python will raise an attribute error. And it'll be up to wherever in the code you tried to call the last name to handle that attribute error. So you either catch it and do something with it, or you just let it go all the way to the top and it crashes your program. Deleters are pretty much the same as getters. If the attribute for the property doesn't exist, then Python will throw an error. So you can either let it throw the default error, throw your own error, or instead of deleting the attribute, just set it to none. And this pairs well with the suggestion to return none in the getter. The reason I suggest none is because it behaves in almost the exact same way as deleting the variable. When we set the variable to none, the reference count for that original data goes down by 1. If doing so causes the reference count of the data to reach 0, then the memory containing the data will be reclaimed. The difference here is that the delete will also remove the variable name from memory, whereas setting it to none will allow us to keep it. So setting attributes controlled by properties to none instead of fully deleting them will help avoid exceptions that are caused by attempting to access attributes that no longer exist. So I have a deleter for first name and a deleter for last name here. And first name, I check to see if it exists first, and if it does exist, then I will delete it. If it doesn't, then I raise an attribute error with my own custom message explaining that it doesn't exist. And then for last name, all I do is just set it to none. I don't actually delete it. And because of this, the getter for last name will actually work out great because it'll either return a string for a last name or it's simply going to return the value none. And then in our code where we try to access last name, we could have an if statement that checks to see if the value is none. And if it is, then we can do our own handling of that, whatever it might be. It could be something that's simple to ignore and we don't have to worry about it. It won't crash the program, it won't break anything. Or we could say, hey, this data is wrong and then act accordingly. As for setters, they're only called when we perform assignment operations on the property. And assignment operations are statements, not expressions. So they do not return anything. So while it won't cause problems to put a return statement in your setter, it will be practically useless because there's no way to capture that return value. So instead, just raise an exception. And just like getters and deleters, one of the various existing Python exceptions will be more than enough, like the value error, for example. And when it comes to setters, we do want to raise exceptions because it's in the setter where we are performing the input checking for the value we want to store in the attribute that the property represents. If the attribute is meant to be a specific type or has any other specific constraints, raising exceptions is the only way to enforce this when using properties. So I don't do anything special with the setters in this one, other than that first name and last name will check to see if the value is a string type, and if it's not, it will raise an error with the message last name must be a string. Otherwise, it will set the value. Alright, so that was a pretty lengthy explanation for error handling with properties. Fortunately, the demonstration code is pretty straightforward. So we create a pilot object and store it in a P1 with the first name Crozo and the last name Oswork. and then we print out both the first and last name here. Then we try to set first name to an integer. That's going to cause the exception to be raised here in first name because it's not a string, and we're going to catch that exception so we can print it out. We're going to do the same thing with last name. We're going to try to set it to Boolean true, and that's going to raise the value error as well, and we're going to print out that error message. Then we're going to delete first name and last name. Now first name, it's going to actually delete the attribute. Last name is just going to set it to none. After we delete both of them, we're going to attempt to print both of them out again. Now for first name, as you see here, it's going to check to see if the attribute still exists. And when it sees that it doesn't exist, it's going to return none. Alternatively, if this was a critical attribute, we could have it raise an error. And last name, it's just going to return the attribute no matter what, but because we have the deleter only set it to none, that won't cause any issues. So when I run the code, we get Crozo Oswork, then we get the first error, first name must be a string, then the second error, last name must be a string, followed by none and none after we deleted both of the attributes. Well, quote unquote delete. One of them didn't actually get deleted, we just set it to none. And that's about it for properties in Python. So I hope you've enjoyed this video and found it helpful, and if you did, then please hit the like button and leave a comment below to let me know what you think. And if you want to see more, head on over to Wayfair Coding Academy channel to check out my other content. And while you're there, subscribe to the channel to stay up to date on new stuff as it comes out. Thanks for watching, and I'll see you all next time.